If you take a sandbox and start pouring a thin stream of water right into the middle, the dry grains immediately soak it up, turn dark, and settle into place. Apply a little bit of heat to that wet patch, and the water evaporates. What's left behind is no longer loose dirt. It bakes into a hard, rigid crust. Now cover that hardened crust with another layer of dry sand, add more water, and heat it up again. Repeat this exact sequence 3 or 4 times, and you build up stacked layers of solid, artificial rock hidden right under the surface. Finally, dump a bucket of water over the whole thing to flush away the loose topsoil. What emerges from the mud is a perfectly stepped, multi-layered miniature canyon. It takes about 2 minutes to pull this off in a backyard, but it perfectly models the exact mechanical laws that carve out the most massive geological formations on Earth. So what happens when nature runs this identical experiment, but leaves the clock ticking for billions of years? To find out, we have to rewind about 4.5 billion years. Long before there was any solid stone to carve, the Earth was an ocean of glowing, erupting lava. Over eons, the extreme heat radiated out into space. The planetary surface began to cool, eventually freezing that liquid magma into a rigid outer shell. Nature had finally poured the base layer of its sandbox. Then came tectonic uplift. Deep subterranean pressures caused sections of the crust to buckle and rise. A massive flat block of stone, what we now call the Colorado Plateau, was heaved thousands of feet up into the sky. The towering canvas was locked into place. All it needed was a tool sharp enough to cut it. Fast forward to about 5 or 6 million years ago. A seemingly insignificant stream of water begins to flow across the top of this newly elevated rock. This was the infant Colorado River. Even today, if you look down at a bend in the river, the water itself is entirely dwarfed by the landscape surrounding it. But water is relentless. As it flows, it picks up microscopic grains of sand and gravel. Those tiny particles act like liquid sandpaper, dragging across the bedrock and wearing it down, millimeter by agonizing millimeter. The river functions as a continuous high-speed conveyor belt. While the water cuts down into the stone, it also grabs millions of tons of eroded sediment and carries it hundreds of miles downstream to clear the path for the next cut. There are no sudden explosions here. It is a hyper-focused, endlessly repetitive grinding action, slicing straight down through the crust. To truly see the work this river has done, you have to look up from the water and examine the towering vertical walls it has exposed. Like the sand in our experiment, this rock face shows distinct horizontal layers, marking different eras. The top limestone was laid by ancient oceans. Descending deeper, you hit sandstone from prehistoric deserts, and eventually, dark rock born from volcanic ash. Once the river slices the initial vertical trench, the newly exposed walls come under attack from the sky. Freezing rain expands inside cracks to shatter the stone, while wind and gravity pull chunks of the cliff face down. The rubble piles up at the bottom until sudden, highly concentrated flash floods rip through the narrow gorges to violently flush the debris away. The river cuts down and the weather cuts wide. Together, they transform a single deep slit in the ground into an intricate, sprawling labyrinth. Step up to the edge today, and you can see the final result of that collaboration. The flat plateau simply drops entirely out of sight. It is a continuous, jagged scar stretching for 400 kilometers. In some places, the floor is over a full mile below the rim. It is almost impossible to reconcile the vastness of that void with the microscopic friction of a single water drop sliding over a stone. But it is the ultimate physical proof that time and relentless repetition will eventually overpower any immovable object. Whether you are watching a 2-minute demonstration in a sandbox or a 2 billion year process in the American Southwest, the mechanics are identical. Massive, permanent changes rarely happen because of a single catastrophic event. True, lasting power comes from invisible consistency. It is a slow, methodical trickle of water waking up and doing its exact job every single day. The same rule applies to human endeavor. Tiny, highly focused efforts, when compounded over a long enough timeline, will yield unstoppable results. Keep carving your own path, no matter how small the daily progress seems. And if you want to uncover more of the mechanics that shape our world, hit the subscribe button right down below.